I do register the morning. Actually, I really need help, but like I need to go to the like that's why I don't think I'll be able.
Hello everyone. Thanks for coming. So let's start.
Yeah, that's the check it out.
Alright, so welcome to tRPC Speaks. So some of you already been here a few times. As you all know that tRPC software, we are like an end-to-end digital consultancy company. So we're working on the like a project base, and we're helping the clients in the different industry. So we've been here in Thailand for more than 8 years already. We're originally from Norway, and right now this is headquarters here. And we have a team in Norway and also in Thailand. So we have almost 200 people and 20 plus different nationalities. So you might see different nationalities in this office. Yeah. So just a quick about service, right? So we are helping the clients kind of a retail, e-commerce, finance. We have different clients, different projects all the time, and we do all the end-to-end stuff for the software engineering, and also we have consultancy services and also digital marketing. We have a data analyst, UX UI design service as well. Try to follow on our social media, Facebook and LinkedIn. So we always share our updated projects, case studies, and also the events and our cultures, what we have done so far. Yeah, we always share, and also upcoming meetups and what we are doing. So please stay in touch with us via the social media as well. Yeah, just a quick about who we are as well. So we working very hard. Yeah, of course, and also we are party harder. So just a quick show of our our activities here at different trip, and also inside, outside, we are going every parties. So we do a lot of parties in house as well. Our team is very open and very diverse, and then we always aim for the best and quality. Yeah. And we also did a lot of sports. Our people have a lot of different clubs tennis, running in the park, and also they do a lot of activities and gym and play e-sport inside the office. Yeah, we have a lot of different games, and we eat hard as well. We have a free lunch in the office twice a week, and we also have others activities. And of course we are hiring. Yeah, so if you are interested to join with tRPC software or More46 or Property Flow, we always welcome anybody to join. Or even you are not looking for the job, please kindly share the very good opportunities to your colleague, friends. We are looking for cloud, backend, QA, data analysts, finance, UX, UI, project deliveries, project orders. Yeah, all those should be opening. And they can also send the CV to jobs@7bigsoftware.com, or they can also visit to our career page, 7bigsoftware/career. Or they can also, talk to our people here after the event. My name is Joseph. I'm from talent acquisition team, and we also have talent acquisition team here. So today, our meetups are about a Node.js, and we have two speaker, Sijan and Denis. They will talk about how's the Node.js things going on. And you can also scan this QR to keep in touch with us. We always have upcoming meetups. I think next few weeks we have again, and also all the time we have interesting topics shared with the community what we have done so far. Yeah, please stay tuned. So I would like to invite our first speaker, Sijan. Welcome. Yeah.
So I'm going to be talking about deploying your application to Lambda. So in this case, it's going to be Node.js application. So who am I? So I'm Sijan. I'm a full stack developer. I am also a developer associate for AWS. So I'm going to be giving you the developer's perspective on deploying AWS Lambda. So what is the agenda for today? I'm just going to go on brief about what serverless is, what is Lambda, and what exactly is the serverless framework, which is actually going to help us deploy the code. All right. So this is just the developer perspective on what serverless is, and by the word it might mean there is no server, but it actually doesn't mean that. It's just you don't have to manage it, somebody else is going to be managing it. You mostly focus on your business. And in AWS, it previously meant only for functions like Lambda, but now it's a database, which is DynamoDB, also Aurora, and for messages like SQS and SNS, and for storages, it's S3. You don't have to manage anything; everything is managed for you, and you pay as you use. So it's really a convenient model. So some benefits is of serverless is it's highly available and fault tolerant. So it of course doesn't mean that let's say if you have a data center somewhere in Singapore and you put all your logic in, all your business logic in there, and you expect it to be fully available, you have to have multiple users. So yeah, just put it out there, and you pay for the value. You of course don't have to hire or rent out dedicated servers. So you just pay per value, and it scales with usage. So I'm going to give a demo on how it actually is on Lambda. So now, what exactly is Lambda? So people here might not know what Lambda is. It's not related to lambs. So it's just virtual function. So AWS will give you a dedicated. AWS already has a data center where it just runs your Lambda function. If you invoke a particular function, it will create a space for you, and it will just execute your code. And it's very affordable, and it runs in demand. It's limited by time, so it does not run forever. So it has a cutoff of 15 minutes. So if you have a business logic that requires you to use more than, all right. So if you have a business model that requires you to use more than 15 minutes, like let's say data importing job or some complicated task, you better be using something else, not Lambda. So yeah, also it runs on demand. Like I mentioned, it just basically when you invoke it, we create a particular space for you to run your code. And scaling is automated. So, okay, let me just show you quickly on what the console looks like for Lambda. So yeah, this is the basics. So I actually had to try a lot of things for the demo, so you might see a lot of things in the functions. But I like to go and show you this first. Okay. So AWS Lambda. So you are not limited to only Node.js. You have like a lot of other programming languages you can use: .NET, Go, Python, Ruby, and also you can have your custom anything. So AWS provides you with a specific APIs where you can run a programming language of your choice. So let's see if I just run something. So it actually, it's a demo, it executes from the Lambda. So now let's see how Lambda responds to events. So Lambda is actually event driven, right? So as you can see here, a streaming analytics service is actually calling Lambda, and it has a particular it's running one Lambda at a time. But if you bombard it with like multiple requests, it will spin up multiple Lambda containers for you. And yeah, so this is what I mean by its scale is automated. But it doesn't mean that it's like scales infinitely. It has a limit of 5,000 concurrent requests. But if you are an enterprise user, you can scale it up to 20,000. We did have a client who wanted to use 20,000 requests, but yeah, it never reached on the production, so you might not need 20,000 requests per second. So, and for the price, if you can see, for the first million requests, it's actually free, as you can see here, the price. Then it starts to slowly increase. And just to inform you, it's only for 128 megabytes and runs 1 second. So let us create a function. I'm going to use a blueprint, so I'm just getting started with Lambda. As you can see, it's very secure. You can also put like permissions if you want. So mostly DevOps cloud architect stuff, and acknowledge it. So it just create a function. So it just creates a very simple function which is going to serve a static file for you. It will take a while. Maybe you can relax. Alright. So as you can see, it actually deployed, and you already got a URL you can use. If I go to the URL, it actually serves as HTML page. So the topic is about how to deploy your application to Lambda. And one of the easiest way for you to deploy is like just write your code in the console here. So it's a Cloud9 console, but as a developer, would I recommend it? I would not, but there might be a case where you might want to serve a simple function, so okay, it might be alright, but not a really good approach. Also, I want to show you something about Lambda. Maybe it's you can specify the RAM, but you cannot specify the CPU. So the CPU scales along with the RAM. So if you want, you could just increase it into 1020. So 10 gigabytes, and it's gonna give you like around 6 vCPUs. Maybe it might be old news, but yeah. Alright. So now, how do you actually deploy your code? So, like I said, the first way is that you can directly do it in the console. And another way is like we have something called infrastructure as a code. So AWS by default gives you something called SAM, serverless application model. So I have tried it, and it's not really developer friendly. I would say it was kind of painful, but it's just a simple YAML file, and you can specify your functions, your runtime engine, and so this is one way to deploy your code. code using SAM. So as you can see here in the hello world, it basically has a tested YAML and an index.js. So if I actually deploy it, it's just going to console log some values. But there's probably a better way, which is actually serverless framework. So you guys might be asking, like, why is there so many things? Like, normally we are familiar with Terraform, and this is the AWS SAM, but there is another tool now called serverless framework. So yeah, the LAM is there. So I just googled why it's a better approach, because I did ask my cloud architects. They do not prefer to use Terraform for this, because serverless actually is really good for Lambda. It's actually a specific tool just for deploying your code to Lambda. And as you can see, like, it's just really good. And what is the best framework? Serverless. Maybe it just Google prefers serverless. So now, what actually does a serverless framework do behind the scene? Serverless framework will transform your YAML file into a CloudFormation template, I would say. So what is CloudFormation? CloudFormation is like Terraform. If everyone is familiar with Terraform, it helps you build your infrastructure. And CloudFormation template is native to AWS, so AWS will understand this. So I could just demo you. So I have a project here that I will demo, but it basically like will convert everything that you write into a CloudFormation template and build up your infrastructure and also deploy your code. So let's go to the next slide. So now let's just see what serverless is. So if you are familiar with Node.js, so you could actually just directly install using npm I. It's too small. So you could actually just do npm I-g. Just it will help. It will install the serverless for you. And once it's installed, you could actually run the command to see what it does. So it will give you a list of like things it can do. Like it can have a standard boilerplates for Node.js starter, HTTP API, schedule task, SQS worker. So it's pretty straightforward. But I already have a demo for you here, so which I will just show you. In serverless, we will actually just write a YAML file and we will specify our handler or a function that we want to execute. And we can have like multiple plugins also that we want. So right now, just for the example, is for the GET request if somebody calls our endpoint. So this is just a standard like get starting template. And once you actually have the function ready, we could just use something called serverless deploy just to deploy your code. But I would not recommend it. We should use CI/CD for that. I'll just show you a demo on that too. Now, okay, show you some code. So this is what is just show you as an example of an event-driven system where someone in the internet will call the Lambda and it puts your data into the SQS. Then there will be a consumer pulling the data from the SQS and will be sending an email out. So I use the SMS just for demoing the email functionalities. All right. So let's see how our serverless template looks like. So as you can see, I actually have a function here for producing the data. I just create a post request to it. And this is actually a standard template from serverless. I just added a few things like SMS and some permissions here. So also you can be very permissive. Right now I give it the full permission, but you can also specify on which resource is allowed to send the request. And you can specify the node version. And also, if you can see, I just wrote AWS, but you can actually use it for Azure or GCP. And I think there might be more. So, yeah. And yeah, like I said, like we could use multiple plugins. Like right now, I'm using something called serverless lift, which will easily help us create some queues. So that's why I'm using the plugin. And as you can see, I can also define some resources here. So in here, I'm actually creating an SMS topic called meetup topic. Then I'm also creating a subscription where it will send an email to meetuptest@mailinator.com. So this is actually the serverless file. And now let's see what the code looks like. So if you can see, it's calling handler. If you go to the handler, it's just exporting a producer and a consumer. So let's say what a producer does. Producer is simply like accepting the data and sending it to a SQS queue. So that's it. And consumer is like running in the background, which will just pull the SQS queue and just publish it to a SMS topic. So I actually have already deployed the code, so I will not do it, but we could just do serverless deploy to deploy the code. Let's see how it looks like. So yeah. So right now I'm not using any Webpack tools to transform the data, transform the code, but you would likely be using TypeScript to transpile. So it needs to be transpiled to just JavaScript. So right now you could easily like come here and edit it. But okay, so here is the code for the producer, and here is the code for the consumer. And also, it actually also deploys the SQS for you. If you go to SQS, so you can see like we have like two queues here. So one is just a normal queue, and one is a dead letter queue. And actually, I did not have to specify anything related to a dead letter queue, but it was the plugin which is smart enough to create a dead letter queue for you. So. Alright, so how will it work is I will just need to send I'm just making a curl request, and let's see, we change the body. So it's basically like going to send the data to the producer, and then the producer is supposed to send it to the queue. So I might not be able to demo it because it's too fast for us to see. But hopefully the intention is that the email is sent to our particular meetup email. Just copy. I hope someone is familiar with Mailinator. It's just a public email box. So yeah, so it sends a message and hello people from the meetup. So the idea here is like everything here is like serverless. You did not have to manage anything. Everything is done for you. And this is just an example for an event-driven system, but you could also replace this with many other things if you are going like with the large-scale applications. Now, okay, some stuff that I would recommend when you go use serverless is use MIDI. So MIDI is similar to Express if people are familiar here with the Express. Let me just open that. So yeah, here. So it is like similar to Express. I'll just show you a demo code because here it says code is greater than 10,000 words, so I will just stop speaking. So it's basically like I showed you, like there will be a handler, but why I would recommend using MIDI is because we can do multiple things here. We could parse, we can validate, we can handle the errors. And it's really useful when you have like a very complex application and you need to reuse the code. So yeah, it's just a really easy to use tool. And something else that we normally recommend is using serverless compose. So previously we had issues with deployment where we had to wait because the deployment was, how do you say, it's just serial, I guess I should say it's serial. Just wait for the first Lambda to deploy, then it moves to the second one, which is kind of like pain. So the serverless came with a tool called serverless compose, and it looks very simple. I have an example here. So it basically will be something like this, where you just specify all your services, and as you can see, this is the API gateway which needs to be first deployed before your, let's say, back office or order. So, and you can specify like, okay, the order actually depends on the gateway, so it will actually wait. But the first this will be deployed, then this tool will follow. So that's one example for serverless compose. And let's go to the next one. Some plugins that we normally use is for, let's say if you want to transpile the code, you could use the serverless webpack. And if you want to run it locally, we could use something called serverless offline. So it's there's like a lot of tools and a lot of plugins for you to play around with. Example also is with the caching. So if you want to cache in the API gateway, it's really easy to do. All right. So I guess yeah, that's it with the serverless demo. Anyone have questions? Anyone has questions?
Where's the server?
It's with AWS, we can't say it.
Is serverless free service that's provided, or do you have to pay for it?
So of course it's not free, it's based on how much you use it. It's like, it's not going to be expensive as let's say an EC2 running continuously. But let's say if you have a very specific job of, let's say, image upload, which needs to create a thumbnail, but it's just called like, let's say, once a day. But yeah, that's a good use case for you.
And does it scale based on the limitation of the memory that you provide? Because when we were setting up Lambda, right?
Yep.
You set up like a memory limit.
Yeah.
So does it scale based on that limitation? Or is it just purely based on the amount of requests that it gets?
Based on the amount of requests, right? It cannot be like, because if a Lambda is already serving another function, another request, it needs to spin up a new one. All right. Any questions? No? Hope you enjoyed. Okay, thank you so much. Alright, so the next speaker, our tech lead, Denis.
Hi guys. Oh, too loud. Yeah, a lot of people, thanks for coming. I'm a little bit nervous, never spoken in front of so many people before. Anyway, the pursuit of end-to-end type safety. Yeah, basically I'm going to try to describe that there's a way to keep your productivity up and sleep better at night. All right, let's go. Before we go further, let's define type safety. And I want to ask you guys, put your hand up. Do you use TypeScript? Yes, pretty much everybody. Who doesn't use TypeScript, please come have a talk with me later. I'm gonna try to convince you why you should. And other than that, TypeScript police will come and arrest you if you don't. Yep, that's us. All right, so let's define type safety, right? So take a look at this function and tell me. All right, before you take a look at the function, also take a look at the usage of the function and tell me if you see any problem. Will this work? Will this work? Maybe. Actually, the answer is like you probably don't know, right? You can't tell. Maybe it will work, maybe it won't. There is no information. Okay, so to make it better, we should actually define the type. What is a cookie, right? Okay, a cookie has an ID, which is a string. All right, and it returns like, it has also a name and calories. So let's take a look again. Okay, so now actually we know that the previous one won't work. Now once we define the type, our ID tells us, okay, the 420 has to be a string, not a number. And the cookie doesn't have a weight, it has calories, right? So once you define the types, your ID will help you. So let's fix it. Now we fix the usage and everything is working fine. All right. So that's what I mean by type safety. I want to know the input and output of the function. Now let's define the ends. So we were talking about in pursuit of end-to-end type safety. We define type safety, let's define the ends. So you have a client, right? Maybe a web browser, maybe an application, mobile application. You have an API, basically a server running somewhere, okay? And then you see you have the client is calling API, and API is returning some response. So you have request, response, all right? Then probably you have a database somewhere there. Your server is called database. Again, you have request, response, right? I have a question. Do you know what is the request here? Like, what is the structure of request? What are you supposed to send? What is going to be the response? Who defines this? Where can you see it? Like, did you define the type, or you have documentation, or what, right? And some people will say, okay, I don't have documentation, I don't have types. I just use JavaScript. And like, I'm a full stack developer. I just look at the source code, right? And I know I'm just one man on the team. I know what's there, right? It's not a big problem. I have a small project. Okay, sure. That's fine, maybe, but you can still improve. But if you're working on a bigger project, right, the things are not that simple. So Conway's law, American scientist, basically says that if an organization is designing a system, any type of system, the structure of the system itself will follow the communication structure of the organization, right? So this is typically what you will have on a bigger project, right? You will have the team backend building API and database, team web responsible for the website, team iOS, Android doing the applications, right? Maybe there's a team service doing a microservice because yeah, why not? And all of those teams have to communicate to each other, right? Now, question is, how are they going to communicate those lines? How are they going to describe to each other what is the request structure, what is the response structure, right? Now, it's a lot more complicated because team web cannot go look at the source code of team backend, right? It's impossible, right? It's becoming a lot more complicated. So, some of the pain points we can summarize, right? So, inefficient communication between teams, right? We have also bugs and bad developer experience when you have lack of types. We showed it before. Also, even if you do have types, you might have different types between client and server. They may not match because you've been manually defining them. That can happen. And also, if you have many clients, you can have duplication of effort actually writing those clients, right? So if you have Android client, you have to write the types for the request response. And then you have same for iOS and web. All right. So we can solve this. The traditional way is design first approach. So you design and document your API first. All right. You write some kind of documentation. Then you implement the server based on this documentation. And then you implement the client based on this documentation. The typical tool is OpenAPI, right? Swagger. So you write your API documentation, API design spec in YAML files, and then you have a website where you can share this documentation. So you send this documentation to your team A, team B, team C. They take a look. They implement the client, the server, based on this documentation. So we are able to solve the first point, right? The communication part is solved. But you still have the bugs, right? Because I still don't have the types, right? You only have documentation. All right, so you write manual types. Based on the documentation, you go in and write, okay, get cookie request, get cookie response, and so on, right? Okay, good. But you have to do it for the server and the client, right? So can we share this type somehow? Maybe. So typically this is a type client, right? So you maybe say, okay, get cookie function. This is the request, this is the response, and you fetch something from your cookie API, and you get something, okay? But actually, are you sure that the fetch cookie.com will return you the get cookie response? Maybe not, right? You're not totally sure because you typed it by yourself. Maybe you made a mistake. You don't know. But at least this is better than nothing. All right, so we kind of say like, okay, bad developer experience and bugs sort of solved. But we still want to keep the types aligned, right, between server and client. So some ideas. Okay, you can expose types via npm package. So you write types one time, and then you put them, package them in npm package, and let the clients use them, let the server use them too. So you have one source of truth. You can also use a monorepo. So if you're in monorepo, you don't have to create a separate npm package. Everything's there. Everybody can access. But monorepos have their own problems. Like if you have so many teams, how are you going to organize the deployment of monorepos? It's not so easy. All right. Finally, you can actually generate types from Open API. Right. This is actually what we should talk about. So the workflow here, we will call it spec-first approach. So you write Open API specs, right, in YAML files. Then you generate the types, and you generate the client. You can also generate the server from the Open API spec automatically. You don't have to write them. You click a button to generate. Computer generates you those types. Then you use those types to implement your server. And the client you don't have to implement because you generated the client from the Open API spec. It's automatic. And if you go to Swagger editor, you will see the generate client there. And you can generate your client for like pretty much any platform, like TypeScript Fetch, TypeScript Axios. It will be a type client. You can start using it. You don't have to write manually anything anymore. Swift, I don't know, Java, Android. Yeah, you can do it. You can also run something like this. So you can, let's say you want your own client, right? But you just need the types. You need the schema in TypeScript, right? But generated. So run this thing, and then you can use your types in any way you want. Create your own client. Go crazy. Then there's another one, code-first approach. So some people say, I don't want to write YAML. I just want to write my code, right? My server, right? Okay, you can do this. Implement your server first. You can stop it. You don't have to write full implementation. You can just like put in like an empty function, but you should define what the function input is and output is. After this, you generate the OpenAPI specs from the code in number one. And from that, you can generate the client from the OpenAPI specs, right? So the way it kind of looks like is, if you're familiar with Node.JS, and you can use decorators on your create cat DTO, for example taken from their site. And this will generate you a YAML file automatically, right? And you can have a Swagger API ready for you to browse and share with your teams. And you have a client here as well. You can have a client for any platform. So really cool. Some teams prefer this approach. Some teams prefer spec-first approach, because when you're writing a spec-first approach, you don't need to know how TypeScript works, for example, right? You can have an architect come in and just write a bunch of YAML files. He doesn't care how you're using C#, TypeScript, right? So pain points, feels like we solved them, right? Those pain points, okay, much better now. But isn't there a tool that already kind of does this? Like, do we have to orchestrate this all ourselves? The answer is kind of yes. GraphQL solved this, so designed by Facebook, right? To kind of solve specifically the problem of many clients, many teams trying to use the same API. They have no communication, no direct communication between each other. So they need to share the API definition somehow. And at the same time, all these teams have different requirements from the server, right? Somebody needs one part of the API, somebody needs another part of the API. So GraphQL is there, a typed query language in the runtime, right? But GraphQL comes with its own problems. Before you jump into GraphQL, make sure you understand all the downsides. This topic now about GraphQL. There's another one, tRPC, right? An RPC protocol by Google. So this one is complicated. The learning curve is steep, and it's more suited for like microservice and microservice kind of communication, because gRPC is not fully supported on the web browser. It uses HTTP2 spec, and HTTP2 is not fully supported on the browser, so you're not getting full benefits of gRPC. gRPC is supposed to solve the problem of, like, it's supposed to be super performant. It compresses your messages into small parts, so it's a lot more efficient than, let's say, sending JSON or XML over the wire, because it uses protobuf. Yep. All right, so cool, but wait, didn't I promise you that we're gonna have a solution, right? What is this? This doesn't all look, it's complicated, right? You're probably thinking like, wait, I have a small team, right? I don't have time to do all of this. I'm just like 2 or 3 developers working on small projects. We're like full stackers, right? We're a team of full stackers who know everything. Like, it's just 3 people. All right, yes, there is a solution. tRPC. Let's look this. tRPC is basically a way to build APIs in a type-safe way. Really fast, with great fast, I mean you will be working fast. The API itself, I don't know, probably fast. But you will be moving really fast, and really you will be confident that things are working correctly, because it's 100% type-safe. You won't be wasting your time on manually defining types or sharing types with your team, right? Because they're right there in the code. So, what now? Demo, okay. How it works. Everybody can see? It's too big, maybe. Actually, I have everything here ready. Maybe I should start removing stuff. But let's start with basics, maybe. So tRPC. This project has tRPC already installed. And it's a Next.js project, by the way. So you can use tRPC with Next.js. You can use tRPC with Express. So it doesn't really matter. What do we have here? We have a server. Right. We have a router. Right. This is our router. So imagine this is your Express router, and this is the start. This is where you define everything that your API exposes. At the moment, our API exposes only cookie router. So if we go inside there, we will see that we are defining a new router, specifically for cookie domain. And we start with tRPC procedure. Let me remove this stuff maybe. Probably going slow. Right? You have an input, and you have the actual implementation of the function, what the function will do, right? So let's say we have a cookie, right? And we want to return the cookie. So the route is just basically very simple, get cookie, right? So first thing is we define the input. So you can see over here, we have defined that the input is going to be an object with one property ID is a string. Now this is the actual handler. In here we receive the input, and if we try to type the input, if you take a look at what we have inside the input, you'll see that we have ID. All right. Let me actually add something here more. You want me to add maybe. Suddenly I have a name. Right? So cool. It knows. But the cool part is that it not only knows the type, it also validates. That means before it arrives to the query part, if the client didn't send you ID string and name string, it will not go here. It will return an error, and your client will receive a validation error, right? So here, you are sure that once you have validated this object, thank you, man. We need this thing, but we need to automate it. So yeah, once you are in the query, you know you're safe to use the input. All right. Cool. I can change this to number. Suddenly, ID is a number. It's not just a string, right? So it will follow the full thing. And there's a lot of validations. I can do like mean. I don't know why it doesn't work right now. It does. Yeah, mean. So I can do more validations. Like think of it as joy, or what do you have? Yep. Trust validate. Yeah. This validation is done by a library called Zod. Zod. Yeah. So really, really cool. Okay, so this is the first part. But then the second part is, okay, we're just returning something about our cookie. So here we return Oreo. Hillary is 500. Great, we define our router. Of course, it can be more complicated. You might be going here into database, right? But we are, for the simplicity sake, we're keeping this really, really simple, okay? Now let's go to the client. So this is the React, right? Next.js page, just the home page. We are trying to get a cookie. The cool thing about tRPC is that, let me delete this stuff, is that it immediately gives you a client to use. I don't have to create any client. I just define the route, and the client to call this route is available. So all I do is tRPC dot, and then it has a cookie there already. That's my route. Dot again. Okay, on the cookie namespace I have get cookie. Cool. And on the get cookie I have a use query. Who here uses React query? Put your hand up. One. Okay. Use React query. Go talk to Rafi after, if you don't yet. So okay, use query, and we need to pass some input parameters, right? And what are the parameters that we need to pass? ID. ID is a required parameter. If I don't pass ID, it won't validate. So let me try to pass 420. Oh, it works. It shouldn't. Oh, that's because we forget to change it to string. Let's change it back to string. Squiggly line. Number is not assignable to type string. No more errors. And did you see how I can easily navigate to the backend? How amazing is that, right? You will be able to discover your source code much faster. All right, let's fix it. No more error. Great. Now we can use it. So I have cookie, and if you are familiar with React Query, this is how it works. Okay, you have cookie inside the data. You will have your cookie. This is all we have, fully typed. Did I define this type anywhere? No. Let me navigate to it. There you go. Takes me back to the server. How cool is that, right? Developer experience, level 9,000. All right, so that's cool, but let's see one more thing. Have you ever created a middleware in Express.js? And have you ever tried to make your middleware context typesafe? Like for example, you put like context.user equals something. Not so easy. Well, with TypeScript, no. With tRPC, it's really easy. So let's go to our key router. Let's say we have an admin user, right? And admin user is supposed to get a bigger cookie. All right. So all we have to do is we have to add a middleware. Just like in Express.js, we have a use. And to the use, I'm going to pass a middleware that I have already defined. It's an authentication middleware. Let me take a look what's inside there. All right, very simple. Let me remove console log. So in here, all I say that, okay, I have context coming from my request, right? It's a middleware. I have headers in there. This is the typesafe, okay? I have authorization and, okay, secret. Don't do this in production, you know, right? This is a demo. And if secret is secret, then, okay, admin is going to be true. All right, save this. Go back to cookie. Now, if I request context in my query, what I can do is I can say context dot, I have isAdmin suddenly there. Magic, right? So if he's admin, let's give him a bigger cookie, otherwise, no, thank you. Just a small one. Great, right? TypeSafe, maybe, let's see. I remove use, off, suddenly I have an error. Context doesn't have admin. Yeah, try doing this in Express. Yeah, you can, but not that easy. Right, and that's what I mean by type safety, right? Yeah, I think that pretty much concludes our demo. It doesn't work because it didn't run the server, but I can. Not that it matters, but just to prove my point. Yeah, okay, he's admin. I'm admin. So that's the demo. Thank you, Sijan. Let's continue the slideshow. It worked. So, but okay, you probably like, I don't want to use tRPC. What the hell is tRPC? RPC is a remote procedure call, right? It's not REST. My boss told me to build a REST API. He didn't tell me to build tRPC. Okay, there is a very similar framework called Zodios. Works pretty much the same. You have your client, you have your server, and you have your definition of the API. Kind of looks like OpenAPI spec, right? Sort of. And this is going to be just a REST API, fully typed. Use this if you don't like tRPC. For me, working on a medium-sized project, tRPC doesn't matter. Like, take a look at what Facebook does. GraphQL is RPC protocol. It's not a REST, right? gRPC is RPC protocol. It's not REST. So you don't have to use REST all the time. Right? Check out this library. And Zod. So a lot of things that we saw here is made possible by Zod. So Zod is a validation library. And Zod is really cool because it can infer your types from the validation schema. So you only say that it's going to be ZString, and then it can infer the TypeScript type automatically, right? That's amazing. And Zod is really cool that it can export its schema into other things. Like you can export your Zod to OpenAPI schema. You can export it to JSON schema, and vice versa. You can do the same thing. So check this one out. I think this is where this is what people are going to be using a lot. All right, we forgot to define the end for the database, right? The database is your other end. You also want to be type safe there. And so what to do about it? This is what I recommend, Prisma. Amazing, amazing developer experience, super type safe. Please try. You will not go back to anything else unless your boss demands you to. MicroRM, close, but different style. It's object-oriented, while Prisma is like kind of functional. MicroRM is a lot more difficult to use, but it has good type safety features, not as good as Prisma though. Yeah. So, and if you're using SQLize, put your hand up. All right, good. Throw that thing in the trash. Finally, but is it really type safe? Like really, like everything we discussed, is it really type safe? No. JavaScript is a dynamically typed language, right? Because whatever you wrote in your TypeScript, right, it is still going to be transpiled to JavaScript. And if your server or your database, for some reason, is not sending the right thing, you will not be receiving the thing that was described by the type, right? So runtime validation is still required where it matters. I will not be doing runtime validation in my tRPC projects. There's no way for anything to go wrong. Like very little chance, right? But some scenarios, especially if like you're building like a mission critical APIs, systems maybe going to space, yeah, you should do validation in runtime as well. Or just don't use JavaScript at all. Go for a typesafe language like Rust, yeah. So where it matters. Yeah, thank you. Oh, by the way, the images that you saw here, generated by DALI, yeah, it's publicly available right now. If anybody wants to buy this, I can sell to you for $5. It's royalty. It took me like 1 cent to generate out of 24. Thank you. Questions? Anybody? Are you going to be using tRPC from now on? If no questions, we can go have some pizza and beer, free flow. Enjoy.
Before the pizza, we would like to have some feedback from you guys. So yeah, we would like to make our meetup better for everyone. So can you please give us your feedback? And after that, of course, you can get our free pizza and beers. Free flow. All yours tonight. And we have another request, so can you guys please stay for 1 minute? We would like to have a group picture. So, Sijan and Denis.
Forced to do this.